Welcome, ladies and gentlemen, to your MN46 notes, where we're going to talk about surface area of prisms. This is section 12.2 in your textbook. And before we get into example number 1, where we're going to find the surface area of the rectangular prism there, let me just make sure you're understanding what the word prism means. It is a 3D shape where you have two congruent faces that are called bases that are parallel to each other. Now, the rectangular prism, which is essentially where you have a base of a rectangle, is here in example number 1. And it's interesting because you really don't know which one is your base per se. You could really say that what it's sitting on is the base, or you can say, since this right here, this face, and the face opposite of that, back behind the figure back there, they're parallel, and they are congruent. So bottom line, folks, is a prism has two congruent bases where they're parallel, and a rectangular prism is kind of an oddball. So let's start with this one, though, where we're finding the surface area. And really the best way to get into this is to take each face by itself. So for instance, let's take this one right here, this front face, where we have, I'm going to just draw this picture here really quick, where it's 8 feet long and it's 2 feet tall. Then, and I'm just going to, and of course, if we multiply those together to find the area, you have 16 feet squared. There's one of them. Now, because there's a front and a back face that's the same dimensions here, you're going to take your 16 feet squared times 2, because there's 2 of them, and that's going to give you your area of 32 feet squared. So that's the front and the back of this prism. Then, if you want to find the area of the sides faces, we have a 2 foot by 3 foot. Actually, I'm going to flip that around because I don't want to mess that up here. We have 3 feet and 2 feet for that side right here, and that's going to give us 6 feet squared. And again, we have a left and a right side, so we have 2 of those. So that gives us 12 feet squared for that one. So right now we have this, which is the left and right area of the faces, this, which is the front and back faces, and because it is a prism, we have 6 sides. We have one more to focus on, and it's the top and bottom. So now we're going to look at this top area, and I'm going to draw that one out. And the top has a dimension length of 8 feet and 3 feet. I have to look at that for a minute. You see this 3 down here, that's also the same as that dimension right there. So it's an 8 by 3 foot, or a 3 by 8 by 3, and that, when you multiply, gives you an area of 24 feet squared. Again, there's 2 of those, which is going to give you 48 feet squared. So now we have the top, bottom, left, right, and front, back. And we're going to add up all of our clouds here, and I'm going to do that in black. So we have 12 plus the 32 plus the 48. So the total surface area is going to give you 92 feet squared. And that's the surface area, total surface area. So if you were to take the skin off of this rectangular prism and flatten it out and find out how many squares fit in that, it would be 92. Okay, so now let's move on to another prism here. We have example number 2. It says find the surface area of the pentagonal prism. Now, the reason why it's a pentagonal prism is that the base that's parallel to the congruent base, or the 2 congruent bases that are parallel to each other, is this right here. So there, it's not sitting on the base, but if you were to tip it forward onto it, then it would be. But that and the back are identical pentagons, and because they're pentagons and that's what the base is, we call it a pentagonal prism. Okay, so we are going to find the surface area of this shape. Now, we have 2 distinct shapes. One is the pentagon, so I'm going to try very hard to draw it, and I can't draw a pentagon to save my soul, but here we are. And we also, if you look, this right here, that's a rectangle, and I'm going to draw the rectangle down here. And that rectangle is 3.5 inches by 2 inches, because this is showing that this is 2 inches, this is 2 inches, this is 2 inches, and so on. So we have a 3.5 by 2 inch. Now 3.5 times 2 is going to give you 7 inches squared. And again, because we have a pentagon here, if you count around 1, 2, 3, 4, 5, there's going to be 5 of these. So you're going to multiply that area by 5. So you have 7 times 5 is going to give you that 35 inches squared. And I wish I could say that that is all there is, but the pentagon is kind of the bigger deal here, of course, because it's kind of going back to what we had just learned about finding the area of a regular pentagon. So I'm going to, again, just try a little bit harder to draw a reasonably regular shape here. That's a pentagon. I'm going to start in the center here. I'm going to cut this up into triangles, 5 equal triangles. I have 2 inches right here, and because I have 5 equal triangles, I definitely need my height of that triangle. So I'm going to bring this, I'm going to use blue here, I think. I'm going to take this triangle out and bring it over here. Now I know this is 2 inches. I need to find this height. That's kind of my issue right now. Now if that's 2 inches, and let's see, we have 360 degrees divided by the 5, so we have an interior degree measure. So this angle right here is 72 degrees. This one is 72 degrees, and so on. That means then that if, you gotta love my multiple triangles here, I'm going to take this triangle and bring it over here. Okay, that means this full angle here is 72 degrees, but half of 72 degrees is going to be 36 degrees. So in here we have 36 degrees. So that's 36 degrees. This base of this part of the triangle is not 2 inches, it's going to be 1 inches, or 1 inch I should say. And again, we are all about trying to find this height, because once we have that height, then we can find the area of this pentagon. So we need to find that height. Now we have one side, we have one angle, that's where SOHCAHTOA comes into play. We have an opposite side of the angle we know. We want the adjacent, so that is definitely tangent. So tan of 36 is equal to the opposite side over the adjacent side. And when you cross multiply, you have tangent of 36 times h equals 1. So we take 1 divided by the tangent of 36, and that gives us a length or a height of 1.38. And that is in inches. Okay, so all that work to find was just to find the height of that original triangle. So now we're going to go back to the purple triangle here, or the blue triangle, and we know that the full base is 2 inches right here. We know now that the height is 1.38. So I'm going to find the area of the triangle, which is base times height divided by 2. And I also know that because this is a pentagon, we're going to multiply that by 5 triangles. By 5, because there's 5 triangles. Number of triangles. So the area of the hexagon, or I keep wanting to say hexagon, the pentagon, I'm going to have to calculate it here. It's 2 times 1.38 divided by 2, although I could have just divided those out instantly, times 5 gives me 6.9 inches squared. Now, remember there is a front pentagon and a back pentagon. So we need to multiply that by 2. And that, my fine young ladies and gents, is going to give me an area of 13.8 inches squared. So, what we have here, one cloud is the area of all the faces going around the pentagons, around the figure, and then this other cloud is the pentagons front and back. So if I go 13.8 plus the 35, we're getting an entire surface area, and I'll do it in red down here. Surface area equals 48.8 inches squared. So we're really putting a lot of math that we've learned over there into one space here. Okay, so it's just kind of more take it step by step by step. Don't skimp on your work because it'll confuse you otherwise. And then you go from there. Okay, this last example is instead of actually finding the surface area, they're giving it to us, and they're wanting us to find the unknown variable x. So I'm going to start with using the word surface area equals. Because this is a triangular prism, and again, it's because our parallel bases are triangles. You know, so here's a triangle, here's a triangle. Those are the only congruent shapes that are parallel. We have here 2 right triangles, and then we have 3 sides going around that right triangle. And I think just to simplify this, I'm going to actually draw out each of the shapes so you can really see it. So here's the one shape. We have an 8 base and a 17 height for that triangle. And then we have a rectangle that's right here in the front face, which is 8 by x. We don't know. And then we have another rectangle that's 17. So now I'm focusing on, I'm going to erase this right here. I'm focusing on this side right here. It's 17 by x. And then the back one, look at what we have back there. I'm going to do it in red. We have this hypotenuse right here, which we don't know the length of, and it's that back face that's associated with that hypotenuse. And so I'm going to draw that last one in red, where we don't know this yet, and the height we don't know. But we can find this right now by using Pythagorean theorem. So I'm going to go, let's see, my one leg squared plus my other leg, so 8 squared. I'm going to write up here, 8 squared plus 17 squared should equal c squared. So that c, or this length right here, is going to be 18.8 inches. And I get a little worried because I always have you guys check my quick calculations. I'm going to just do it again really quick to make sure I don't mess up here. Okay, so we now know that this right here isn't a question mark. It's an 18.8 inches. And really, now what we're just going to do is we're going to cut right through and find the areas that we know, like this triangle. It's 17 times 8 divided by 2. So the area in here is 68. This rectangle is 8x. This rectangle is 17x. And this rectangle is 18.8x. That's all we can do right now. So let's cloud all the singleton areas. Now up here again, we knew, I'm going to take this surface area away here for a minute. We know that the surface area was 616 inches squared. We also know to find surface area, you find the area of each of your faces and add them together. So I'm going to take each one of these shapes here. And actually we have, I almost forgot, we have, remember, 2 triangles here. There's 2 of them, so we have to go 68 plus 68. So there's my top and bottom. Then the front is 8x. The right side is 17, plus 17x. and then plus 18.8x. So here's my bottom, here's my top, here's my front, here's my right side, and here is my back side or back left. We add the 68 plus 68, and that's going to give me the surface area, because remember, this here is given to us right from there. 616 equals 136 plus, now we have 8 plus 17 plus 18.8, and that's giving me 43.8x. I take 616 and subtract 136 from it to start solving. We have 480 equals 43.8x. We divide out by 43.8 to solve for our unknown x, and voila, we get 10.96. You know what? Because we rounded here to the nearest tenth, and it's going to end up being to the nearest tenth. Oops. It's going to be 11.0 inches. That is the unknown. So again, the rounding, just so you know, my calculator, I'm getting 10.958. And this, I want to round to the nearest tenth here, so I don't even need to look at the 8. But this 5 is forcing that to be 0, and this to go up to 1. So we have 11 inches for our unknown. Well, folks, this is how we find surface areas of prisms. You find the area of each of your sides and add them together to find your surface area. Just be careful not to forget any of your sides. Of course, if you have a regular pentagon, hexagon, and so on, you have to do a little bit of triangle trigonometry. And then when you don't know a side, you have to work backwards and find that length. We'll take any questions you have tomorrow. Thanks for tuning in.